Okay, in a typical calculus course, you will see fractions all over the place, and they will be buried all, numerator, denominator, and all sorts of multiple places. So the technical term for when we have a fraction inside of a fraction, we call that a complex fraction. So I wanted to take some time and just look at some of these fraction rules and see some situations that you might typically encounter in a normal calculus course. So I'm going to actually put some numbers onto these rules so that you can kind of see that, yeah, I've kind of seen this before, and yeah, I kind of understood this. So for the first rule, I'm going to just take a whole number. Let's take 3 times 2/5. Sorry, let me try that again. Should look like a 5. Okay. And what this rule says is if I multiply a whole number times a fraction, I multiply the whole number piece times the numerator piece, which gives us 6/5. Okay, the second rule says we have a fraction divided by a whole number. So we'll take 1/2 and divide that by 3. Okay, what this rule allows us to do then is that takes the denominator of the numerator and multiplies that by the whole number that we're dividing by. So this becomes 1 over 2 times 3, or 1/6. Okay, now what if we're dividing by a fraction? Instead of the fraction being in the numerator, so we'll take, say, 2 over 1/3 and compare that, kind of use this rule here. So if you remember, you've got that rule that says if you divide by a fraction, multiply by its reciprocal. So this would translate into 2 times 3 over 1, which is 6. And that's really what this rule is just reminding you of, is something that you've already seen before. All right, this next example is a great way to illustrate a nice little shortcut with fractions and especially non-common denominators. So let me take something like 1/3 plus 3/5. Let me try to write that in a little bit nicer. Okay. Obviously, they have their common denominator is going to be 10, or 2 times 5. But what this rule allows us to do is when you're trying to add common fractions that don't have a common denominator, only multiply the thing that's missing. So in the 1/2, the 1, what's the 1/2 missing of the common denominator? It's missing a 5. So that's 1 times 5. And then the 3/5, so what was the 3 missing? The 3 was missing the 2 from the common. And then I can multiply that out. Let's see, 5 plus 6 would be 11 tenths for that one. Okay. This next rule is a nice little rule if I sort of need to simplify out a fraction. So let's take something like 1 plus 2 over 3. I can actually break that up into 1/3 plus 2/3. Okay. Next rule, if I've got some sort of common factor in them, sort of a variation of that last rule. So say I've got 6 plus 9 all divided by 3. I can break that up and get 6 over 3 plus 9 over 3. And then I can divide both things by 3. So that gives me 2 plus 3, which is 5. And then the last one is a fraction divided by a fraction. So 2/3 divided by 4/5, which we know if you're dividing by a fraction, you multiply by its reciprocal. So that just gives you sort of a one-step sort of, oh, this is what I do. So 2 times 5 would be 10 over 12. And then in this case, we could reduce and get 5/6. Okay, so our first example is just 1/2 divided by 3/4. So we're going to multiply by the reciprocal. I do notice that the 2's divide out, which gives me 2/3. Okay, number 2, negative 2/3 multiplied by the reciprocal, so 9/5. The 3 divides out, and that leaves me with negative 6/5. Okay, a little more complicated example, number 3. So I'm going to do a common denominator with the numerator and denominator separately, but I'm going to do a common denominator and kind of get that complex fraction thing going on here. So in the numerator, I would like the denominator to say 2. Well, obviously the minus 1/2 piece is fine. What was that whole number missing? The 2 was missing the common denominator, which was 2. The 3 plus 2/3, I want to make that say thirds. So the 2/3 piece is fine. And so the 3 is missing a 3. And so up top, in the numerator of the numerator, I get 2 times 2, so 4 minus 1, so I get 3/2 up here. And I get 9 plus 2, so I get 11/3. And then I can apply the rule that we just did in the other examples. So 3/2 times 3/11. And doesn't look like anything divide out there, so we get 9/22. Alright, which brings us to number 4. Okay, so the denominator of the numerator, so we're going to have a 2h there. And let's see, so that's going to be x plus h times x minus h. And what is, so the 1 plus x over h, what is it missing of the common? It was missing the x minus h, and then minus 1 times, and what was the other 1 over x minus h, what was it missing of the common? That was x plus h. Alright, and then let's see, I got x plus h over x minus h over, well, distribute the 1's in, so I get x minus h minus x minus h. And the x's cancel out, the h's give us negative 2h over, and then I'm just going to take advantage of one of our other rules where we're essentially going to drop down all the denominators. So 2h times x plus h times x minus h. And the 2h's divide out, so I'm left with negative 1 over x plus h times x minus h. Okay, so the first thing we're going to do with number 5 is we're going to bring down, get positive exponents. We're going to take care of the exponent issue with the negative there. And so I'm going to bring those both down to the denominators of the fraction that's associated with it. So that gives me 1 plus 2 over 3x over 1 plus 1 over 5x. I'm going to do a common denominator. In the numerator, the common denominator is 3x. And so what's the 1 missing? It's missing the 1, the 3x piece. And then plus 2. And then the denominator, so we got a 5x there. So what was that first number missing? That first number was missing the common. And then if you're not quite sure, you can always re-simplify, pull the fractions apart, divide, and you should end up with the same phrase. Okay, so multiplying, and then doesn't look like there's any combining like terms we can do, but I get 3x plus 2 over 3x for the numerator, and the denominator I get 5x plus 1 over 5x. And then if I multiply by the reciprocal, so I get 3x plus 2 times 5x over 3x times 5x plus 1. And we can distribute this in. So it's not. I would always say follow directions of whatever your calculus teacher's given you. So we could stop here, or we just distribute it on and keep going. So if we distribute that, we get okay, so one thing I do want you to notice is they have x's in both positions. So I can essentially divide out those x's. And then I can distribute in the constant. So that would give me 15x plus 10 over 15x plus 3. Now I do want to emphasize we cannot divide the 15x's out. Even though you see a 15x in both numerator and denominator, there's a plus sign in between them. So it has to be something you're multiplying in order to get it divided out. So you just can't do that. Okay. Number 6. Okay, sort of a similar type of process. We're going to do common denominator of the numerator first. And so the x is missing the 3x. So we're going to multiply it by 3x. And in the denominator, we get 6x for the common. And that x is missing a 6x. And then I'm going to distribute, or multiply, and then there's no really combined like terms I can see. So that'll give me 3x squared plus 2x all over 3x divided by 6x squared minus 5. Okay. Blah, blah, blah. Alright, so if we multiply this out, we get 3x squared plus 2 over 3x. And this is 6x squared minus 5 over 6x. And then we're going to do the multiply by the reciprocal rule. So that's 3x squared plus 2 times 6x over 3x times 6x squared minus 5. And just like last time, hopefully you notice that there's actually more we can divide out. So 6x divided by 3x, we actually get a 2 up top. So if I distribute that in, I get, sorry, having color issues here. I get 2 times 3, so 6x squared plus 4 over 6x squared minus 5. That's what that simplifies down to. And there's not, that's it. That's all we can do on that one. Okay, a few more examples. So we've got negative exponents again, so we want to do that same, bring the exponent down and then try to find a common denominator. So this is 1 over x squared plus 3x over 1 over x to the 4th plus 2. We're going to set the numerator to have a common denominator of x squared. That's 1 plus 3x times what's missing, which was the x squared. And then the denominator will set up as x to the 4th. So 1 plus 2 times what's missing, which is x to the 4th. Multiply that out, so we end up with 1 plus 3x cubed over x squared over 1 plus 2x to the 4th over x to the 4th. And then seems like we're rinsing and repeating the same process. We'll multiply by the reciprocal. So 1 plus 3x cubed times x to the 4th over x squared times 1 plus 2x to the 4th. Okay, just like last time, we noticed that, sorry, let me get this back here, that x squared and x to the 4th divides with, gives us x squared in the numerator. So when we distribute that in, we get x squared plus 3x to the fifth over 1 plus 2x to the fourth. And that's our answer for that one. Okay, number 8. Okay, so sort of an interesting as to what kinds of things can we break this up as our fractions go. This is a good illustration of that I can split this up into two different fractions for this first one. So I can bring that as 3x minus 1 over 2x, times 2x, and then 3x minus 1 squared in the denominator, minus 3x squared over 3x minus 1 squared. And the only real benefit to doing that is we can divide out an x minus 1 squared there for that first term, which gives us 2x over 3x minus 1 . Okay, and then minus 3x squared minus 3x minus 1 squared. And that's about it, unless we wanted to common denominator and put it back to the way it looks, but that's that's it for now. Okay, in the very last example, we're going to illustrate a sort of a factoring technique rather than a fraction technique, and try to make it a little bit easier for us. So looking at the numerator, what's the biggest GCF we can take out? Well, I know for a fact I can take out a 2x because I see both things in the numerator have that. And I see that they actually both have an x squared minus 1 cubed. Sorry, squared would be the biggest GCF that I can take out. And we're going to leave the denominator with this term. Let me write it a little bit nicer. So x squared plus 1 squared. All right, well, what got left behind? The x squared plus 1 didn't get to come out. The 3, so times 3, and then everything else in that term did. Next door we have, let's see, the 2x came out and the x squared minus 1. We got two of those, so we're just left with one single x squared minus 1 term. Let's see, so that's 2x over x squared minus 1 squared over x squared plus 1 squared times whatever I simplify here. Well, this would give me 3x squared plus 3 minus x squared plus 1. Okay, so last thing would be 2x, so just combine like terms, x squared minus 1 squared over the x squared plus 1 squared, and then the numerator, 3x squared minus x squared gives us 2x squared plus 4. And in calculus, a lot of times your answer is going to look just like that. They're not going to make you go in and distribute. But it depends. It depends on the directions of the assignment and what the teacher's trying to do with you. So